Hello, my name is Espen Krogh. I'm the CEO in Prediktor, a company located in Fredrikstad, Norway. So in this session, I will talk about a theme that I'm pretty engaged with because I believe we can see some emerging patterns of digitalization strategies that work pretty well for industries. So I will first tell a bit about the challenges I see with actually going digital with industries, and then look at a solution that might be the thing to do. And then later about the concepts around the solution and whether these concepts are taken up with industries and standardization bodies. Finally, how Prediktor can assist you in getting this in place. So, challenge is that plants and assets across the broader energy segments have massive volumes of real-time asset data. And in order to go to data-driven operations, you need to actually figure out how to use that data. The data though are in quite high volumes. Some 100,000 data points in one asset into like millions of data points across the enterprise. And those data points have a specific nature. We call it operational technology. And it's a bit different than IT. First of all, it has less of the context, etc., that you typically find in IT data. And it's real-time data. So real-time data streams are typically transient in nature. You need to capture the data elements before it changes if you want to act upon it. Such data points will often be represented by a system close to the various equipment on the assets. In oil and gas, it's called information management system. Many other places we call it SCADA, or in manufacturing execution systems. So the thing is that when you have those other usages of real-time data and in the enterprise, and you would like to plug applications into those data streams, you typically do what I call a deep integration. You figure out each specific data element you need, and you bring that into that new application. And this goes for all the data streams or all the applications you have that you would like to plug real-time data into. Typical examples are enterprise resource planning, asset management, and integrated operations. All of these connections, all these arrows, are actually work done by engineers trying to figure out which data points they need. So this is what I call data plumbing, and this is a hassle, and this is what actually hampers big enterprises for going digital. I will try to exemplify that a bit more so that you understand the nature of this challenge. So we have a plant with various systems, and then we have applications we want to plug into the data streams from that plant. So that's the generic challenge. Next I will show you an example. So this beautiful site is midway up in Norway in the coastline. It's a field called Ormen Lange. This is a gas reservoir field, and there's a lot of wells going down to the gas reservoir, and the wells then shuffle gas and oil and condensate water into a production pipelines going into the cleansing process onshore, and after being cleansed, this is exported to England where it's used. So there are certain challenges with the structure of this asset. There are long production pipelines, 120 kilometers, and those pipelines go through a subsea landslide, meaning it's quite bumpy. So you can have everything from accumulation of liquid to congestion of pipes because of subzero temperatures, etc. In order to cope with this and understand the state of the subsea process, the operator has decided to invest in what they call a flow assurance system. The flow assurance system makes the complete state of the subsea process evident to the operators so they can cope with the challenges as they appear. Now, in order to bring such a flow assurance system in place, it needs to consume a lot of real-time data points, 3,600 in this case. The data points originates in various equipment collected through the safety and automation system, and then further propagated to information management system. Now, in order to get those 3,600 data points in place, this is the actual process to do that. So we as an app provider, we get a set of analog drawings on paper, and we mark up the drawings with all the equipment where we believe we need the data from. We take this drawing, send it to the EPC, and the EPC then relays that information to the supplier of the equipment. The supplier identifies the data items and sends the response back to us. And this is an example of a response I received when I was chief engineer, something like 15 years ago, in a project like this. And already from the text in the email, we can see there's a lot of uncertainty here. A vacation has gone, so this is a response coming several weeks after. And when we open the Excel sheet to look at the details of the various data items we'd like to collect, there are some quite worrying comments there. So a comment like this might be the right one, must be verified in the detailed configuration of the SAS supplier. Hence, in order to understand if you have the right data point, we need to communicate with a specific person that did a specific configuration around this equipment. Does not exist in SAS. Two tags exist, which one should they use, etc., etc. There are many challenges with this process. It's lengthy, and often you will have to run these cycles many, many times. And this is what we call data plumbing. Many iterations, significant number of people involved in this from many different organizations. There's no value by this process in itself, but it's needed to get the application doing the thing it should do. So this is very costly. And when you put this costly activity out in all applications that need to consume the real-time data and further scale this to all the assets in the enterprise, you have a situation where actually there's a combinatoric explosion of integration costs across your enterprise. So this integration challenge by itself limits the enterprise in scaling out new innovation across the asset portfolio. And many times it blocks the digital journey, and data-driven operations remains a distant dream for those companies. Now, is there a solution for this? Well, I believe we need to figure out if there are other areas around us where we see that somebody figured out how to solve this case of interoperability. So where should we look? I believe we should look in the mirror. In the mirror, you will see a human being, and we humans are fantastic at interacting and having interoperability with other humans. An example is like this. We're having a session right now. Usually I'm on stage and maybe 100 people in the room. And we 100 people have perfect interoperability during the session time, like 20 minutes. The other examples, on a football court, you join your team on the court, you meet 11 other people you maybe never met before, and the 22 of you have perfect interaction and interoperability. The 90-minute plus the match lasts. And you have similar thing with road and traffic systems. You can have interoperability with thousands of others. And being a citizen by itself requires you to interact and interoperability with potentially millions. So humans are really capable of advanced interoperability. Now, how do we do that? Well, let's go back to the example I had on the football court. And let's take this person. He's a spectator to a football match. And when he starts to look at the match, a set of concepts appears in his mind. There's a match, there's a team A and a team B, and they participate in the match. So all of these elements, match, team, and participation, are just abstract concepts. They're not tangible and doesn't exist in real life. However, there are other things that exist, and they hook up those existing things, the tangible things, into the same information structure. And eventually everything is then connected to the information model. So this information model is the way Leopold processes information that he receives through his senses when he needs to understand what is happening. If he's going to have a good conversation with his fellow spectator, it all depends on the two of them sharing the semantics of this information. If you don't share the semantics or have another idea of what is actually happening, interaction might not work very well. So takeaways are that the same real entities, like the people participating in the match, they could be a father, a son, they could be a colleague in other information models, but they are the same thing, but in different information models. So no model is the right one. You use different models for different purposes. The meaning of the information model must be shared with others for them to work. So we humans use information models to be able to interoperate properly. So I believe that most of our social constructs are really there to create shared meaning in our information models, like parenting, schooling, sports, etc. Machines, however, they don't know how to socialize, so you must assist them. So taking this problem again with a lot of data plumbing, is there another way to do this? And I believe so. With many of the scenarios in industries and things going on, there you can find a standardized information model. And then you can expose that there's real-time data structures through that standardized information model. And the application that needs to be plugged into this can have been pre-programmed to understand the types of that information model. And then you have more or less a plug-and-play experience in connecting to it. Same goes for asset management here. An example here is a standard maintenance model, and with enterprise resource planning, a standardized asset structure model called the ISIS 95. Now, if we're talking about real-time data, we need a concept that can shuffle real-time data through the structure of a standardized information model. And is there such a technology around? The answer is yes. It's been around for more than a decade, and it's called Opc Ua. So Opc Ua is the only real-time protocol that can transmit your real-time data stream in the context of any specific information model you choose. And this puts you up with a much better scenario when you would like to deploy your apps and connect all their assets to those apps. You have more or less a plug-and-play experience. So out of this, we can see an emerging pattern. There are existing investments that you need to protect. You cannot change them from a wide range of suppliers on many years. But anyway, you need to bring information out of those assets and investments and technologies. And doing that, there's a belief there should be a standardized context of that information so you can understand them and provide that standardized context and the types of that through an open protocol. Eventually, you can buy smart applications that understand the industry-defined types and have been pre-programmed to find them and connect to them so that no engineering is needed to get data into the apps. We've been thinking about this for quite some time in Prediktor, but of course we're not the only one that have been thinking about concepts like this. So Namur is an organization that has been around for quite a few years. They were the inventor of the automation pyramid that has been used for decades. But Namur has recognized that this information model, even though it does the tricks for having stable and good control and production, getting data out of this pyramid can be a challenge. Namur Open Architecture is Namur's own answer to the challenge they see. So with Namur Open Architecture, they see a way where they can bring standardized information and information context through open protocols out to new applications for monitoring and optimization. while preserving security and stability in existing investments on the field and in the process. So Namur established in 1949, more than 150 members. Those are the biggest player in the heavy asset industries. They publish recommendations like this for automation and digitalization purposes. So this recommendation here was published this spring, so it's really fresh. But the concept is like this, using standardized context information on open protocols. Now, we also have another very active standardization organization called Industry 4.0 Consortium. Out of this comes what they call an Industrial Digital Twin Association that has crafted what they call an asset administration shell. So this is more or less the same concept. There's an asset which represents existing investment, equipment, a factory, etc. And then they provide a digital surface on that asset. So all communication towards that asset goes through that standardized digital surface. And then again, we look at open protocols and APIs and standardized context. Now, what's the difference with Namur Open Architecture and Asset Administration Shell is that Asset Administration Shell is quite more comprehensive, addressing all the use cases with the assets, not only optimization and monitoring, and also adds more dimension to the usage of the Asset Administration Shell. First of all, they think we can have different levels of usage of the same concepts, all the way from the field up to the enterprise. And in different parts of the life cycle of that specific asset, all the way from when it was designed, developed through commissioning and into operations, and then later for decommissioning. So we at Prediktor have been engaged in these concepts for quite some time, and we have an offering that is pretty spot on. What is the recommendation from Namur Open Architecture and aggregating service? So first of all, there's a connectivity to your assets. You can capture the data from those legacy elements and make those data available securely with high quality. Then we make the data usable by mapping them to the standardized context and provision it through Opc Ua and standardized protocols to the apps. So examples of clients that have bought this and get it into operation is Equinor. It's running on Johan Sverdrup field, collecting 200,000 real-time data points, reorganized into ISA S95 information structure. Equinor is happy with this and is now bringing this into a lot of more assets, also renewables. And of course, the reason for this is that on the top from the enterprise, looking out of the asset structure, there will be a standard digital surface for all the assets, so that interoperability becomes much more achievable, and then eliminating all the cost associated with not having that. Semantics becomes a truth, so that you can have the same structure across the enterprise, and this enables AI and ML to be channeled across the enterprise. Again, facilitating standard operations, going from carbon high assets to carbon low assets. I guess this is also important for a company like Equinor. Another example is Scatec, a pure renewable asset owner. It has like 30 to 40 different assets, and they have our system set up on all those assets in order to shield the difference between equipment, regions, etc., so that the integrated operations team sitting in South Africa, Cape Town, can assist in operations of all those assets. Okay, I believe we can assist you in getting the foundation of your digital journey right for your energy assets. And I hope you take contact if this is a challenge you struggle with today. So that's all for me for now. So if there are questions and answers, please come with those.